Hello students. So let us continue with chapter 12 electricity, and our topic is heating effect of electric current. You know that in this chapter we talk about electrical circuits. We have seen the parallel combination and series combination of resistors in the previous videos. And we have also seen the advantages of parallel circuit over series circuit. Now let us see the heating effect of electric current in an electric circuit. Now in the circuit, for the electric current to flow, we know that potential difference is required, and this is provided by cell or battery present in a circuit. Now there are chemicals present in the cell. Chemical reaction takes place within the cell which generates the potential difference between the two terminals, positive and negative terminal. So the chemical reaction that takes place within the cell makes its one terminal at high potential and the other negative terminal at low potential, even when it is not connected in the circuit. But when we connect this cell or battery in any circuit, closed continuous path, then electrons will flow from low potential towards high potential. It means from negative terminal towards positive terminal, constituting electric current. And we know the direction of electric current by convention is opposite to the direction of motion of electrons. So it will be from positive terminal towards negative terminal as shown in the figure. Now we know that whenever electric current flows, so this, because of this potential difference, the electric current flows. But this electric current, if it has to flow continuously and by the same amount, then the potential difference should be maintained by the cell or battery. And this is done at the cost of its chemical energy. So we can say continuously chemical energy is used to maintain the potential difference across the terminals and indirectly to maintain the current in the circuit. So a part of the energy which is supplied by the cell or battery gets converted into, it is used to do two things. One, it is used to do, part of energy is used to do some useful work. And secondly, useful work means when we have bulb in a circuit, useful work is the glowing of bulb. When it glows, useful work is done. When we have an electric fan in the circuit, then motion of the fan, motion of the blades of the fan is a useful work. Okay, so whenever in an electric current, in an electrical circuit, electric current flows, part of the energy which is supplied by the cell or battery, it gets converted into heat energy, and part of it is used to do useful work. Useful work is desirable in all the electrical circuits, but energy which goes dissipated or wasted here in the form of heat is undesirable in most of the cases. For example, when the fan is working for, let us say, for an hour, it becomes hot. You can touch the fan and feel that it has become hot. Even when the bulb glows, you know, most of the electrical energy gets converted into heat energy, and very little amount of it actually gets converted into light energy. Similarly, when we watch TV, if TV is kept on for some time, it also becomes hot. So this heating which is caused by the electrical energy when it flows through any device is actually wastage of energy in most of the cases. Now, when our circuit is purely resistive means in a circuit we have only resistors, maybe in series or parallel combination or a single resistor. So when we have a purely resistive circuit, means which includes combination of resistors alone, then in that case, entire energy which is supplied gets converted into heat energy, because of which the resistors gets heated up. And this is called as heating effect of electric current. And this is actually, there are many appliances which are based on this heating effect of electric current, or which are the applications of heating effect of electric current. For example, electric heater, electric geyser, electric toaster, electric kettle. So let us see here what do we mean by heating effect of electric current when you are asked to write the answer. When an electric current is passed through a purely resistive circuit, as I told you, purely resistive means only a combination of resistors is present in the circuit other than ammeter, key or battery or voltmeter. There is no other device like fan or bulb. The electric energy is dissipated entirely in the form of heat, and as a result resistor gets heated. This is called as heating effect of electric current. And you can name some applications of heating effect of electric current as I have given you the examples now. Now, the amount of heat energy that is produced in a given resistor, when we consider resistor is connected in a circuit, is given by Joules law of heating. So let us see the mathematical form of Joules law of heating, and then we will state the law. So for that, let us start with this. Consider the circuit as shown in the figure. We can see a cell is there, a key is closed, and hence direction of current is shown. A resistor having resistance R is connected, voltmeter is connected across the resistor, I is a current flowing through the circuit or through the resistor we can say. Ammeter is connected in the circuit to measure the current. So consider the circuit as shown in the figure. Let V be the potential difference across the resistor having resistance R. I is a current flowing through the resistor. Now, when current flows, it flows because of the flow of charges. Let us say Q is the amount of charge that is flowing across the resistor in time t. Because you know current is constituted by the flow of charges. So, if Q is the amount of charge that flows through the resistor in time t, I hope you remember what is an expression for I. I is equal to Q by T because it is rate of flow of charges. Now, let us see, to move the charge Q across a resistor which is having potential difference V across it, what will be work done? You know the equation for potential differences, V is W upon Q. So what will be W then? Q into V. So work done W to move a charge Q through potential difference V is equal to W is equal to QB. From where we have got this equation? By the basic equation of potential difference. Now, if you know that work and energy are equivalent, if this much work is done in time t to move the charge Q across a resistor or across a potential difference V, then this much energy should be supplied by the source. Now, energy supplied in time t is equal to amount of work done, that is QB. So now we have seen that work done to move the charge Q through the resistor R in time t, W is equal to QV, as V is the potential difference across the resistor having resistance R. And this work done, how energy is supplied? This energy is supplied by the source of potential difference, that is cell or battery. Energy supplied by the source in time t will be equal to this work done. So energy supplied or energy input to the circuit by the source is QV. So now power input to the circuit by the source. You have studied the definition of power in your 9th class. Power can be defined as rate of doing work or work done in unit time, and as energy and work are equivalent, we can say power is energy consumed in unit time or rate of consumption or transfer of electric energy. So here power input to the circuit by the source P is equal to, if we take the definition work done in unit time, then W upon 2, or energy transferred or consumed in unit time, then E upon T, where E is the energy transferred in time t or consumed in time t. So as we have seen, energy input is QB in time t. So for E we will put QB divided by t. Now we can write this as V into Q by T. Q by T is what? Rate of flow of charge. That is nothing but current, which is I here. So energy power input to the circuit is V into I. Remember this formula, as this formula will be used for the numericals. Now, what will be energy supplied if this is the input power? What will be the energy supplied in terms of power? What we can write? See, P is E by T. So, E will be P into T. So, energy supplied E is equal to P into T. Now, for P, you put VI. So, energy supplied will be P into T, that is VIT. Now, as this is this energy supplied by the cell or battery to the resistor R, which is connected in the circuit, and we have considered purely resistive circuit. So, we know that this entire energy which is supplied, it gets dissipated in the resistor as heat. So, heat produced in time t, if we represent it by capital H, it will be equal to this energy supplied. So, heat produced in time t in the resistor, that is if we represent it by capital H, will be equal to this energy supplied, that is VIT. Now, use Ohm's law for V. We know that using Ohm's law we can write instead of V, IR, because V is equal to IR. So, when we put V is equal to IR, we can write H is equal to I square RT. This H is equal to I square RT. This is a mathematical form of Joules law of heating. This is nothing but Joules law of heating. So, if the question is derive an expression for Joules law of heating or derive Joules law of heating, we can proceed. So, our question was here, what you have done today. Now, you know the answer to the question, what is heating effect of electric current. Secondly, you should be able to derive Joules law of heating or derive an expression for heat produced in a resistor. So, H is equal to I square RT. This is a mathematical form of Joules law of heating. How can you state it? I have not written here, but I will tell you. Now, if H is I square RT, you know that if R and T are constant, then H is directly proportional to I square. Consider the same equation again. If I and T are constant, then H is directly proportional to resistance R. If I and R are constant, then H is proportional to T. So, this can be written in the form of statements from this equation, and that will form the statement of Joules law of heating. You can write the statement as, just listen to me carefully, the heat produced in a resistor in time t or in given time t is directly proportional to square of the current flowing through it. So, when I say heat produced in a given resistor in time t, given resistor means this resistance is constant and time is also constant. So, heat produced in a given resistor in given time is directly proportional to square of the current flowing through it. Or, this is one part. Second part you can write, second statement you can write, heat produced is directly proportional to the resistance for a given current in given time. As I told you, when I and T are constant, then H will be proportional to R. So, heat is produced directly proportional to the resistance R of the resistor for a given current in given time. It means when we keep the current constant and the time constant. And lastly, we can say heat produced in a given resistor for a given current is directly proportional to time for which the current flows through the resistor. So, I hope you have understood this statement of Joules law of heating. Just look at the equation. By keeping two things constant, I have derived the relation between H and the third thing. And so, we have three sentences here. You can form three sentences. So, three sentences together will form the statement of Joules law of heating. You are able to now derive the Joules law of heating and you are able to state what is heating effect of electric current. So, I think so you need to revise this video at least twice. Then only this thing will be clear to you and it should be on your tips. And this formula will be used in numericals. P is VI, H is I square RT. H is equal to VIT, H is equal to I square RT, and the third form of this can be written as H is V square divided by R, then this whole thing into T. That is by using Ohm's law only. But basically for the numericals we'll be using this expression, H is equal to I square RT. So thank you students, we'll continue in the next video.